Hello, welcome to Maths with Jay. So this is a two-part question, and we're starting off by looking at the longer part where we have to show something. And it's telling us which formulae to use, so let's write those down to start with. So we're given these two in the formula book, and we can see that we also need the sum of r from r equals 1 to n. And hopefully you know what that one is. So n over 2 times n plus 1. So that's really the formula that we use. We think of it as the triangle number formula. So for example, if you want to add up the numbers 1, 2, 3 and 4, you could do that by multiplying 4 by 5 and divide by 2. Another way of remembering it is if you look on the line above here, we're really square rooting the sum of r cubed, aren't we? It just so happens that that works out nicely. So square rooting 4 we get 2, square rooting n squared we get n, and square rooting n plus 1 squared we get n plus 1. So however you remember it, that's your formula. So now let's start with the summation that we've been given. So we're summing r equals 1 to n r times r plus 1 times r plus 3. So we can see that to begin with we need to multiply that lot out. So I would multiply r plus 1 by r plus 3 first of all, and then multiply that by r. So that will end up giving us r squared times r will be r cubed. And then we'll get 3r and 1r, so that's 4r times r, and that will be 4r squared. And then finally we'll have the 1 times 3, and then multiplying that by the r will give us 3r. And now we can simplify that a bit by separating it out into the individual sums. So summing that gives us r cubed, and then we've got, well, we can take the 4 outside the summation, so we've got 4 times the sum from r equals 1 to n of r squared, and similarly we can take the 3 outside here. So now we can see where we're going to use the 3 summations we've got at the top right hand corner. So let's substitute those in. So we start off with simply getting n squared times n plus 1 all squared over 4. And then we're going to have 4 times, and then this one is a bit long looking, isn't it? So we're going to have 4 times n over 6. We're simply copying down the formulae that we've got there, n plus 1 to n plus 1. And then finally 3 times n over 2 times n plus 1. So now we've got everything that we need. We just need to multiply this all out, and we're hoping to get what we've been given in the question. And you can see that we haven't been given the complete answer. We've actually got to find one of the numbers there. So where we've got the k, that's a number that we're going to find. Now, although I said we were going to multiply this all out, in fact it's better if we don't have to multiply the whole thing out, if we can sort of start off by taking out some factors. So looking at what we're trying to prove, we can see we have got some things in the answer that we've already got as factors here, haven't we? In each term we have got an n, and in each term we've got an n plus 1. So we could take those outside a bracket to start with. And we might as well cancel the 4/6, that's going to be 2/3. That simplifies things a little bit too. So let's start off by writing this down as n times n plus 1, and see what we have inside our bracket when we do that. So the first one is going to give us n times n plus 1 over 4, and then we've got 2/3. The n and n plus 1 we've already got outside the bracket, so all we've got left there is 2n plus 1, and at the end we've only got the number left, haven't we? Just the 3/2. So it's not as bad as it looked. So we haven't got to do masses of multiplying out. And now I think I would deal with the numbers. So let's have a look at our fractions. I mean, you can see 4, 3 and 2, and look at what we're trying to show. We've got a 12th in the right hand side, and that is what we want to use here, isn't it? So what we're going to do next is just take a 12th outside here as well. So if we do that, then we'll just have whole numbers inside our brackets here. So we're multiplying each of these terms inside of the square bracket by 12 because we've taken a 12th outside. So 12 divided by 4 is 3, so we've got 3n times n plus 1. And then 12, well, 2/3 of 12 is going to be 8, so that's 8 times 2n plus 1. And then 12 times 3 over 2 is going to be 18. So it's looking even easier now. We've just got lots of whole numbers to deal with and some quite simple multiplying out to do. So let's just give ourselves some more space. Okay, that's better. So what we need to do now is simplify the bit in the square brackets. So we're happy with the n over 12 and the n plus 1. Like that. So now we're simply going to be multiplying everything out here. So we've got 3n squared plus 3n. Next bracket gives us 16n plus 8, and the 18 stays as it was. So still a bit more work can be done inside that last bracket. So 3n squared will stay as it is, but 3n and 16n can be simplified to 19n. And then 8 and 18, 26. Right, now what we do next is we look at what we're trying to prove this is equal to. So we've got the 12th n times n plus 1, and the bit we haven't yet got is the n plus 2 times 3n plus k. So we know that one of the factors of 3n squared plus 19n plus 26 should be n plus 2. So let's see if it is. If not, we're in trouble. Right, so n plus 2, and we know that we should have 3n. 3n times n gives us 3n squared, so it's looking good. 3n times 2 is 6n, and we want 19n, don't we? So we want another 13n. So if we put a 13 here, that will give it to us, and 13 times 2 gives us 26. So in fact, we're fine. So we have found that k is 13. So that's the first part done. So in the last part of the question, we just are going to use what we've just done because it says hence, and we're going to use that to evaluate this sum here. So let's just write down what we've got from the first part. So you can see that we know what the sum from 1 to n is from part A. But you'll notice here in part B, we've been asked to work out the sum from 21 to 40. So all that means is that we need to actually look at two sums, don't we? Let's have a look at how that will work. So the important thing to remember here is that the only thing that we know how to do is find a sum from 1 up to something or other, so that we know that both of our sums have got to start from 1. And because we want to know some of the terms from 21 up to 40, we obviously need to start off by finding the sum from 1 to 40, but then that will include all the terms from 1 to 20 as well, which we don't want. So then we can subtract off the sum from 1 to 20. So that means we're just going to use the formula that we've got up there twice. So the first time around we've got to put in n is 40, and the second time n is 20. So there'll be a couple of big numbers, but it will all work out fine. So we have got, first of all, putting in n as 40, 40 over 12 times 40 plus 1 times 40 plus 2 times 3 times 40 plus 13. So that's substituting in for the first sum. And then I don't think I'm going to have room on that line, am I, for the next bit? So let's just put it down here. So then we're going to take away, and now we're going to put in 20 for n. So each time we've come across n, we put down 20. So we've got 20 over 12 times 20 plus 1 times 20 plus 2 times 3 times 20 plus 13. And then if you work out all that lot, you will find that you get 763,420 minus 56,210, and that will come to 707,210.